This is a video demonstration of the user script feature of Everlog Analyser. It's going to get technical later on. Before that, I'm going to explain what are user scripts, why we've added them, and the sort of things you can do with them. This is a data log that's showing X and Y G-force values as red and green on a vehicle during a short run. There's a period of acceleration, period of braking, deceleration, and then a moment of steering here. Now these values are forces applied to the vehicle, so it might be useful for me to add these values up so that I can tell what the total tyre load is on the vehicle. So deceleration is also tyre load. In that case there's a G, 1 G's worth of negative tyre load, but in reality it's all just tyre load. So if I wanted to sum those values, we could add a feature directly to the analyzer that would add a tyre load mechanism. But this is just one example of a function that you would want to perform on existing data. We're not going to know what sort of things users want to do. I'm sure there's going to be lots of creative examples. So what we've done is give the power to create new data types to users of the analyzer. This is done with user scripts. So in the Everlog folder created during installation, there is a user scripts folder, and user scripts are just text files. So the user script that I can use to create a tyre load trace, here now shown in blue, that shows always positive total values of G-forces that the car is experiencing, is created using this script. And this is a plain text file. I'm not going to go into details of that yet, but that is a text file that is placed in the user scripts folder, and if it has an extension of .evl.script, Everlog Analyser will try and load it and run it in order to create this trace. So user scripts give users a lot of power to add new data types. You might want to use data from a completely external source. You might have an external GPS logger, or you might want to use it to interpret data from devices. If you have exhaust temperature sensors, you might need to use a table lookup to convert voltages into temperatures, and that can be accomplished in a user script as well. We hope that users who write user scripts are willing to share them, to place them on the forum, and anyone can download them, drop them in their user scripts directory, and have an enriched experience in the analyzer with new ways of viewing and looking at data. So I'm going to go through an example of how to create a user script. I'm going to write a user script that calculates horsepower, and this is where it's going to get technical, so feel free to turn off. Okay, so to create a user script, I'm going to take this sample script, create a copy of it, and I'm going to name it horsepower.evl.script, and then I can edit that script. So this is the sample script that I've just saved in my Everlog folder as user script. Okay, user scripts are written in a language called Groovy, which is a language that sits on the Java virtual machine. It's quite straightforward but quite rich language, and I'm going to write a script now to calculate horsepower. I'm going to write it in a readable fashion, so it won't be the most efficient, but it should give you an overview of the sort of things you can accomplish and how to go about them. So this user script contains two functions that we need to fill in. There's a once function, and this tells the analyzer what data the user script is interested in. If the analyzer, while it's loading a log, encounters a record that contains all of the data we want, our user script will be invoked. The perform method is where we do work and actually insert data into the data log. So I'm going to go ahead and implement the once method first. I know that in order to calculate horsepower, I care about acceleration and I care about speed. I also care about the mass of the vehicle, but the datalog doesn't know that. However, I do, so I'm going to go ahead and declare the mass of my vehicle as 1200 kilograms. Now, when working with data and using a little bit of physics, we care quite a lot about units, so I'm going to stick to meters per second, kilograms, and then go via newtons to horsepower. So what I want, based on that format, is going to be GPS and acceleration data. Now, this function returns a data type of map, and we declare a map in Groovy with this syntax. Key to this map entry is GPS, and the value will be GPS speed. The second object I want is accelerometer data, and the key to that is Excel, and the key is X to refer to acceleration. You can add as many entries as you want in this map, just so happens that I only need 2. This will instruct the analyzer that if there is a record containing both GPS speed and accelerometer data, that it should invoke my script. Okay. Now, in Perform, we actually do work. So, I need to think about the units that I'm going to be working with, and I need to obtain the GPS speed and the accelerometer data. In order to get the GPS speed and the accelerometer data, to get the speed, we invoke, we use a property which is called values, which is a map passed to the script by the analyzer that contains the values that we've registered for in the once method. And it's a map, so it's the same sort of syntax, GPS dot GPS speed, and then accelerometer data is values dot accel dot x. Okay, so I've now got speed and accelerometer data. I also need time, and we can obtain time using a property provided by the analyzer called time. So that's going to be the basic data that I need to obtain from the data log. Everything else I'll be doing will be inside the script. In order to create horsepower, I need to know a change in time and a change in speed. I'm going to do that using a built-in property that we provide to scripts, which is a simple sort of stack map type object. Now I'm going to assume that I've already placed them in the stack, which I will do straight after reading them from it. So I'm going to need the previous speed for the record before the one that I'm currently processing. And I can get it from the stack by naming the stack I want the value from. I'm not really using these as a stack because I'm going to be popping them immediately after I've pushed them, but it's a convenient way of keeping some state between invocations. I need speed, and I also need the time. Now, I should go ahead and make sure that I pop those, push them on the stack to make sure that I don't forget to do so. To push them onto the built-in stack, we provide the name of the stack you want to push onto, and then the value, speed, and then the same for time. Okay, so I've now got some memory, so that each time I be invoked, I can access the previous value in order to create my deltas. And I need to think about some units as well now. So speed that's provided to this script is in whatever your preference is set in the analyzer. I'm using miles per hour, so I want to convert that to meters per second. I'm going to do that quite a simple way. Convert to kilometers per hour first of all, so that's kmh. Then I'm going to convert that to meters per hour. and then I'm going to convert that to meters per second, so meters per minute, and then meters per second. Okay, so I've got speed in the right unit, kilograms in the right unit. Okay, now I don't want to try and insert any data on the first run of this script because I won't have any deltas. All my data will be fresh, so I can ensure that I'm operating on safe data after a second invocation, single condition like that. So if the value that I've popped from the stack is greater than 0, then I can work. If you try and pop off a name stack, when you haven't pushed, you'll get 0. Right. To calculate horsepower from accelerometer and speed, I need a delta V, which is a change in velocity between the previous record and the current record. So delta V, and that is current speed, which I've obtained from the analyzer, minus the previous speed. So that's going to be my change in speed, and then I'm also going to need a delta T, which is a change in time, and that is current time. Yeah, so current time minus previous time. Now, Everlog Analyser works in milliseconds, so I need to talk about seconds. In order to convert this delta T into seconds, I'm just going to divide by 1000. So that's going to give me, in most cases, as our GPS is working at 10 Hz, that's going to give me a value of 0.1. Okay, now I need to calculate acceleration in meters per second. Our accelerometer returns milli-g. So this value here, Excel will be a number of milli-g. So I need to convert that into g, and then to convert to a decent acceleration, I need to multiply by 9.8 for gravity. Okay, now this is a plain text editor, so I don't have any syntax highlighting or correction checking. There we go, there's a problem already. Acceleration. Okay. Now, I need to work out the distance travelled during between the previous record and this record. Simple component of that distance is speed times delta t for the duration. I want to add the acceleration component of the distance, which is half at squared, where a is acceleration and t is delta t again. So I do that in a verbose way. I want acceleration times delta t squared, half of that. Okay, and for clarity, okay, that's distance. Okay, I can calculate force that's applied to the vehicle, and force is mass times acceleration. Now, I previously stated that the mass of the vehicle was 1200, that's in kilograms, and my acceleration has now been converted into meters per second. So this will be newtons. Now, based on that force, I can calculate work done, which is force times distance, where distance is the distance travelled between the previous record, including the acceleration component, and that work is in joules. Okay, and now I can convert that into power, which is time-based. So that is power, and that is equal to work times the duration in seconds, which is now because we're using 10 Hz GPS, I could just constant that as 0.1 for the time in seconds, but we might at a later time use a higher frequency GPS or a lower frequency GPS, so that's a quick way of calculating the actual number of seconds. And from power, I can go to horsepower. This is in watts. I can now go to horsepower as power over 745.7, which is the conversion from watts to horsepower. So I've now got horsepower. In order to add that to the data log, I call the provided add method with the data and a name. I'd like it to appear as horsepower. And that's pretty much the script. So that is saved into my user scripts folder with a .evl.script extension. So when I open the data log, assuming I haven't made any mistakes, which is certainly possible, we will, once it's loaded, that script will be executed in a linear fashion, as I need to keep state. You can write scripts that don't need to wait for the end of the log if you're purely operating on the values in the record at that instant, and that's how the tyre load script works. Okay, so here's my horsepower data, and we can see that's the yellow trace. We can see that during this short run there was a maximum used positive horsepower of 54.7. This is a short from standing start, short acceleration, short deceleration, turning left and right. That seems perfectly plausible to me. And there's braking horsepower of 107. And you can see the throttle in white and the acceleration in the x-axis in green. And there's, as speed increases, less acceleration implies, or equal acceleration implies more horsepower as speed increases. So that is essentially a dyno built in to the analyzer based on real-world data. Now, I hope you can see the potential for user scripts. There's a vast array of possible uses, and while it does take some investment of time to create the user script, once it's written once, it will apply to all your data logs, and other people can use it as well. So I hope this gives you an overview and perhaps some thoughts on how to create them and what you might want to add. Thank you for watching.